Okay, so far in high school you've been operating mostly with linear measures. Say you're hosting a party and there's a cost of $500 for the venue, as well as a cost of $50 per guest. You can easily use a linear equation to describe this. You also have polynomial measures, such as x squared, which could depict the area of a square, and x cubed, which could depict the volume of a cube. And while these are all great ways of modeling real life situations, you know that there are other situations that can't really be described this way. I want you to take mitosis as an example, the process in which a cell duplicates itself over and over again, multiplying the cell count by 2 each time. Say on day 1 the cell duplicates itself, and now the cell count becomes 2. On day 2 you'd multiply the cell count by 2, and then again by 2 for each day past. This makes sense, but are we seriously going to write the number 2 100 times for day 100? This is where the solution of the exponential came about. Instead of painfully writing times 2 over and over again, we can just put the number of days as a power instead. For example, on day 1, the cell count becomes 2 to the power of 1, and on day 100, the cell count becomes 2 to the power of 100. This way, we now have a reliable and easier way of displaying this type of pattern. This pattern can go by the name of exponents, indices, or powers. This also allows us to create a formula just like our linear equation. For our cell scenario, we can say that the number of cells, n, is equal to 2 to the power of t, where t is equal to the time in days. Okay, instead of n's and t's, let's use x's and y's and graph it. At x equals 0, y equals 2 to the power of 0, which is 1. At x equals 1, y equals 2 to the power of 1, which is 2. This pattern doubles each time as x increases by 1, giving us this shape that describes an exponential curve. But what about negative values of x? If you remember back to your index laws, 2 to the power of negative 1 is 1 over 2, and 2 to the power of negative 2 is equal to 1 over 2 squared, which is 1 over 4, and so on. This gives us a curve that works almost in the opposite way compared to its other half. And that's the curve of 2 to the power of x. And just out of curiosity, have a look at how this curve changes when you have 3 to the power of x or 4 to the power of x. And those are the basics of the exponential curve. Thanks for watching. If you found this video to be helpful, please be sure to like and subscribe. Also, if you have any questions or feedback, please let me know in the comment section down below.